Next topic, distance between two parallel lines. So using slope intercept form, first type. Let L1, L2 are the given parallel lines. We know that slopes of the parallel lines are equal. Let M be the slope of the line L1 and L2. So let C1 and C2 are the y-intercepts of the line L1 and L2 respectively. Then from the slope intercept form of a straight line, the equation of the line L1 and L2 are respectively y is equal to mx plus c1. This is the L1 equation, and that is equation number 1, and y is equal to mx plus c2. This is the line L2 equation, right? That is equation number 2. So now intercept form of L1. So intercept form of L1, 1 implies mx minus y is equal to minus c1. So m by minus c1 x divided by minus c1, right? M by c minus c1 x minus y by minus c1, which is equal to minus c1 by minus c1, that is equal to 1. So here x intercept, that is equation number 3. From 3, x intercept of L1 is minus c1 by m, right? So the line L1 cuts the x-axis at minus c1 by m comma 0, right? So this is x dash x-axis, y dash y-axis, 0 origin. This is the line L1 and this is the line L2, both are parallel. Let P be the point of intersection of L1 and x-axis. So this is the point of intersection. So this point is minus c1 by m comma 0, right? Because OP is the x-intercept. X-intercept is the x distance of P, that is minus c1 by m. So this is for the line L1, right? Based on line L1, the point P is minus c1 by m comma 0, right? Clearly the point P minus c1 by m comma 0 lies on L1, because P is the point of intersection of x-axis and L1. So P lies in both L1 and x-axis. The distance between the lines L1 and L2 is the perpendicular distance from any point of L1 to the line L2, right? Let D be the distance between the line L1 and L2. So x dash y axis, y dash y axis, O is the origin. This is L1, this is L2. So point of intersection P is with L1, right? Correct? Yeah, point of intersection of L1 and x-axis, that is P is equal to minus c1 by m comma 0. So this is the distance, perpendicular distance D. So from any point L1 to the line L2. So particularly we are taking the point P, right? P to L2. So D is the perpendicular distance from any point L1 to the line L2. In particular, D is the perpendicular distance from any point. So we are choosing the point P, right? P is on L1. So P minus C1 by M comma 0 to the line L2. L2 y is equal to mx plus C2. That is the equation of line L2. D is the perpendicular distance from P, the point minus c1 by m comma 0 to the line mx minus y plus c2 equal to 0. We know the distance from the point, perpendicular distance x1 y1 to the line is given by modulus ax1 plus by1 plus c by root of a square plus b square formula. Here x1 y1 is minus c1 by m comma 0, right? And a from the line equation L2. So A is equal to m coefficient of x and B is equal to minus 1 coefficient of y and C is the constant term C2, right? And x1 y1 also we know. Substituting this value, D is equal to m into minus c1 by m plus minus 1 into 0 plus c2 by root of m square plus minus 1 square, which is equal to c2 minus c1 by root of 1 plus m square, right? So this is the distance between two parallel lines, right? General form. So now we are taking the general form ax plus by plus c1 equal to 0, that is equation number 1, and ax plus by plus c2 equal to 0, that is equation number 2. These two lines are parallel, right? Only constant term differs, right? So ax plus b, ax plus b. This is the standard form for two parallel lines. And before we saw the derivation based on slope intercept form. Now we are going to see this derivation based on general form. So we will get the same result, right? So line L1 and line 2 are given two parallel lines. So d be the distance between the given parallel lines. So x dash, y dash, O is the origin. So this is ax plus by plus c1 equal to 0. Then this is ax plus by plus c2 equal to 0. That is, both are parallel. Draw a perpendicular from the origin to the line 1. So d1 and d2 respectively, the distance from O to the line 1 and 2 respectively. So we draw a perpendicular line which meets the line, first line, ax plus by plus c1 equal to 0 at M, and meet the second line, ax plus by plus c2 equal to 0 at N, right? So this one is D, that is the distance between two parallel lines, right? Perpendicular distance between them. And d1, d2. d1 is nothing but OM, right? Distance from the origin to the perpendicular distance from the origin to the second line, OM, that is d1, and d2 is ON, perpendicular distance from the origin to the second line. We know the distance from origin to the line, right? Ax plus by plus c equal to 0 is modulus c by root of a square plus b square. So here d1 equal to c1 by root of a square plus b square, because the line is ax plus by plus c1, first line. That distance is d1 equal to c1 by root of a square plus b square. Similarly d2. So taking the second line, perpendicular distance from the origin to the second line, that is d2, that is equal to its constant term c2 divided by root of a square plus b square. Here the distance between the line 1 and 2 is d, that is OM minus ON, that is d1 minus d2, that is equal to modulus c1 by root of a square plus b square minus c2 by root of a square plus b square. Therefore d is equal to common LCM root of a square plus b square c1 minus c2, right? So they are based on m root of 1 plus m square in the denominator, c1 modulus c1 minus c2 by root of 1 plus m square. Here we based on the same thing, because we know m is equal to minus a by b. If you substitute that value there, you will get same result. So no problem, don't get confused. That is based on m, slope. If the slope is given, then we know the equation, then the distance between the parallel lines d is equal to c1 minus c, modulus c1 minus c2 or c2 minus c1 by root of 1 plus m square. Suppose slope is not given, two equations are given of the straight lines are given. They are, if they are parallel, then distance between them d is equal to modulus c1 minus c2 by root of a square plus b square, right? Some important notes: coordinate of the nearest point on the line ax plus by plus c equal to 0 from p x1 y1 is given by x minus x1 by a, which is equal to y minus y1 by b, which is equal to minus a x1 plus b y1 plus c by a square plus b square. From this you can find the coordinate of the nearest point on the line ax plus by plus c equal to 0 from the point p x1 y1. Suppose a point is given p x1 y1, a line is given, right? Ax plus by plus c equal to 0. So we have to find a point on the line which is very nearest to the point p x1 y1. So that is the formula. From this formula you can easily find the coordinate of that point which is lying on that line nearest to the point p x1 y1. Second one, coordinate of the image of the point p x1 y1 with respect to the line. So see, the line is acting like a mirror. So if you put one point there, one side p x1 y1 one side, then the reflection, that is image on the other side, that is p dash, x1 dash y1 dash. So how to find the coordinate of p dash, that is x1 dash and y1 dash, that is the value, that is the formula for here. So to find the image, so we can use this formula, x minus x1 by a, which is equal to y minus y1 by b, which is equal to minus 2 into ax1 plus by1 plus c by a square plus b square. So these two are very important formulas to find. Thanks.